I love this question. We're near the end of the section, so we know that this is supposed to be pretty hard. And quite honestly, it looks pretty hard, right? We got these different points. There's a lot of math terminology, right? XY plane, the point lies on the line with this equation. B is a constant. This point with the other coordinates lies on the line. What is the value of R over P? P does not equal 0. It seems very scary. There's a lot of heavy math information. But we have some tools for sorting through math information and getting a set of instructions from that without really having to worry about the specifics of the situation. We know that one of our greatest strategies for the SAT math is to plug points into equations. And the reason I love this strategy so much is that there's a huge variety of questions where this works. And we only need to notice two things about these questions, and that lets us use the strategy. We need to notice that there are both points and equations. And look, there are points and there are equations. It's that simple. We got to plug them in. Now, what goes where is really the first part of this. Just make sure you match up the right point with the right equation. They kind of set it up for you. It's in the same sentence. And look, I know that at the end of the day, I'm being asked to find something weird. I'm not going to worry about that now. That's not my job. I just know that because of this strategy, if I have points and I have equations, plug the points into the equations. So let's just start it off. This point goes into this equation. So P is X, R is Y, so R is equal to P plus B. Does that help me? I don't know. I really don't know. Doesn't look like anything that I need, but I just do what I'm told. I'm told by my strategies to plug points into equations, so I do it. Okay, well, what else we've got? We got another point, we got another equation. Let's plug that in too. So, okay, we've got 2p as x and 5r as y, so that one goes in, and that's 5r is equal to 2 times, we got to be careful here, 2p plus b. So I'm going to clean that one up, right? We should multiply out the 2 times 2p, and that's 4p plus b. Okay, so let me just mark down what we have here. We've got this equation, and we've got this equation, and somehow we need to find this expression. So, okay, how do we start synthesizing these things? Well, this is a great example of notice the problem and solve the problem, right? Like that seems kind of obvious, but here's what I mean by that. If I look at the things that I have and I look at the thing that I want, I should look at what's different, right? What's the difference between the two equations that I have and the expression that I want? Well, the expression has an R and a P, and the equations have an R and a P and a B. I don't want the B. So I should probably try to get rid of B. And I can do that by solving one of the equations for B and then using it as kind of a point of intersection situation, a substitution, right? So here's what I mean. Let's convert this expression, this equation, so R equals P plus B. If I subtract P from both sides, I get R minus P is equal to B. And then I can substitute that in for B in the other equation, and that's going to let me get rid of the variable. We do this all the time. We do this with point of intersection questions when we've just got x's and y's and we want to solve for the variable. There are lots of ways to do it. Substitution is one of them. Elimination is another. But the point is we're taking two variables, which we can't really do anything with, and we're condensing it down to an equation with one variable, which we can then solve for. Here it's not working quite the same way, but the logic is the same. We can get rid of the variable we don't want, and that hopefully moves us along. I don't really know. Let's see. So the B goes in, so let's rewrite this here. So that would be 5R equals 4P, and now we substitute this in for B, so that's plus R minus P. Okay. Well, now I can kind of rearrange things. Just my instincts for algebra are I should rearrange it so that all the P's are together and all the R's are together. So I can combine these like terms, And I can subtract r from both sides to get all my r's on one side. That's 4r. And 4p minus p is 3p. Okay. So this is looking a lot better. It's not the same, but it's looking a lot better. Now, there are actual things. There's two paths I can take here. Let me show you the two paths. The algebra path, or actually, you know what? Let's do the strategy path first, because if you don't see the algebra path, you're going to need a backup, and we have a backup. It's basically like, well, do we ever care what r is equal to? Do we ever care what p is equal to? No. We only really care what r over p is equal to, which means that if I need to better understand what's happening here, I can do a little bit of an arithmetize, right? What numbers can I plug in to make r and p in so that they fit in this equation, right? So if I took r is equal to 3 and p is equal to 4, that would be the single laziest way of handling this situation. So that would give me 4 times 3 is equal to 3 times 4, which obviously is true because 12 is equal to 12. So I deliberately picked numbers that worked out nicely. And then if I do that, and I know that I need r over p, well, r is 3, p is 4, so 3 over 4, which would be choice B, which is the answer. So that's one way to do it, right? Like, we never are told to find r and to find p. We're told to find r over p, which is just a fraction, and so we can pick numbers that make the fraction kind of work. And so that's how we get away with not getting down to one variable, right? So like I said before, with point of intersection, our goal is to get down to one variable so that we can solve. When we have one equation with two variables, we are stuck. We can't ever know the value of r and the value of p because we only have this one equation. So we don't know the specific values, but we do know the relationship. And so we can pick numbers that fit that relationship just to give our brain something easier to think about. And then those numbers are going to work, and that's how we can get that fraction. But we can also express the relationship using algebra, and that's the way that the book is going to tell you to do it. So let me just show you what I mean by that. If we were to do algebra, I would say I don't care what r equals, right? Normally in algebra, I want x equals, y equals, r equals, p equals. I want a very simple expression. This time, though, I don't really care. I don't want that. I want r over p. So let's move some stuff around to get r over p. So if I divided both sides by p, I would have 4r over p is equal to 3. Well, okay, that's closer, but I don't want the 4 there, so let's get rid of that, right? So I could multiply by 1/4, which is the same as dividing by 4, because I have a 4 on the top and a 4 on the bottom. And that cancels it out and gets me r over p. And then 3 over 1 times 1 over 4 is 3 over 4. 3 over 4 was my answer. So that's another big idea for the SAT, is that a lot of times with algebra, we cannot solve for the variables. They design questions to kind of mess with us because we're used to having to do that. And so when we can't do that, we feel like we're really stuck. So there are almost always going to be two paths to move forward and to overcome that hurdle. One of them is to just pick numbers that fit in the equation so that we can better understand the relationship between the variables without really worrying about the specific values. The other is to rearrange the equation so that it gives us the result we want. We don't need r by itself. We don't need p by itself. We're not asked for those things. We're asked for r over p. So move stuff around so that you have r over p. We don't do that in math class in school very often, but it's still valid algebra. We didn't learn anything new in order to do that. We still use the normal rules for moving variables and numbers across an equal sign. We just had a goal that we're not used to having. And that's the SAT in a nutshell, right? They take the stuff that we know very, very well from school, and then they twist it up so that we have a harder time recognizing those things, or something isn't quite what we've practiced before. But if we are truly confident with the math knowledge with algebra, then it shouldn't matter because the rules haven't changed. At least the rules of math haven't changed once we've gone on an SAT. So trust yourself, trust your knowledge. But if you looked at this question and had no idea where to start, trust the strategies. Plug points into equations gets the ball rolling. It doesn't completely solve this question for us. We still need to be clever at the end. But it certainly moves the ball forward. So that's the goal, especially on a hard question where things look weird. Don't worry about knowing all the steps at once. Get the process started, and then you might just kind of stumble your way to the answer, and that is perfectly okay. I've been doing this for a very long time, and that's still how I answer some of the hardest questions. I get them started, and I figure it out as I go, and then, what do you know? It works out. That's an okay thing. Get used to that feeling, because that's how you get 800s on the test, is having the courage to try things that look scary. That's how I got this.